Hello everyone. Today we're going to be looking at the uniform distribution. The uniform distribution is a continuous random variable where every point is equally likely. We use the term u of a comma b to denote that a random variable is distributed with the uniform distribution, and x can take on any value over the interval a to b. Some really nice things about it is that the mean, the expected value, is just a plus b over 2, which is the mean of the numbers a and b. And sigma is the square root of b minus a squared over 12. A lot of the times when we have continuous random variables, we can have a function that talks about it, and the function in this case is f of x equals 1 over b minus a. Notice that there's no x in the function, and that's because everything is equally likely, so x doesn't actually play a part in it. If I graph the function, then I get this rectangle. And remember that probabilities are areas, and the area under the curve in some interval here is just a rectangle, and the area of a rectangle is length times width. To double check that this is actually a distribution, we have the total area is b minus a, which is the horizontal width, times 1 over b minus a, the length, which is actually 1. So it is a continuous distribution here. So let's try an example. The amount of time in minutes that a person must wait for a bus is uniformly distributed between 0 and 15 minutes. So we write that x is u of 0 to 15. Mu is 15 over 2, which is 7.5 minutes. So you would expect to wait 7.5 minutes. Sigma is the square root of 15 minus 0, which is 15 squared, divided by 12, which is 4.33 minutes. The equation would be f of x equals 1 over 15. So remember again, it's 1 over b minus a. 15 minus 0 is 15. And here is an example of the picture. So again, it's a rectangle. It's going from a to b, and the height is that 1 over b minus a. If we wanted to find the following probabilities, we would do the following. So for a, we have the probability that x is less than 10. Graphically, that would look like the following. We're going to shade the area less than 10, so I've marked it in gray. Again, the area is a rectangle. The height is 1 over 15. The width is 10. So the area is 1 over 15 times 10, which is 2/3. So the probability that x is less than 10 is 2/3. If I wanted the probability that x is between 5 and 10, graphically it would look like this. Again, the area is a rectangle. Again, the height is 1 over 15. That doesn't change. The only thing that changes in these problems is the width. And the width, in this case, is 10 minus 5, which is 5. So I'm just taking the difference between my 2 points here. So the width is 5. So the area is 1 over 15 times 5, which is 1 over 3. Another question, part C, says 80% of the time the weight falls below what value? So this question's a little different. I'm not looking for the probability. I'm given the probability, and I want to find the x value. So I want to know at what point, so we're going to call it A, is the area under the curve from 0 to A 80%. So I'm going to set up the equation, except again, instead of knowing the length and the width and finding the area, I know the area, it's 80%. I know the height of my rectangle, and my width is going to be A. So I set up the equation, the area equals the length times width, so 0.8 equals 1 over 15 times A. I want to solve for A, so I multiply both sides by the 15 to get rid of it. So A is 15 times 0.8, which gives us 12. So 80% of the time, the wait is under 12 minutes. Let's try another one. So oil changes take between 11 and 21 minutes distributed uniformly. So first we're going to find f of x, which is 1 over b minus a, so 1 over 21 minus 11, which is 1 over 10. Next we're going to find mu and sigma. Mu is a plus b over 2, so that gives us 16 minutes. Sigma is the square root of 100 divided by 12. Remember, this is b minus a squared, so b minus a is the 10, 10 squared is the 100. If I plug that into a calculator, I get 2.887 minutes. And then we're also going to look at the graph. So again, the height of my rectangle is my function, 1 over 10, and the sides of my rectangle are my a and b. So it starts at 11 and goes to 21. So now let's find some probabilities. What's the probability that x is bigger than 18? So again, remember that all these areas are length times width, or the height times the length, or the height times the width, or whatever you want to call those two dimensions. But the height never changes. The height is always f of x, which in this case is 1/10. So we always have something times 1 over 10. And if we're looking at our picture and what we have, x bigger than 18, remember that in our picture, it's 11 to 21, and I want 18 and bigger. So this dimension here will be 21 minus 18. So 21 minus 18 is the width or the length of my rectangle, and the height is 1 over 10. 21 minus 18 is 3. 3 times a tenth is 3/10. For E, I want the probability that x is between 14 and 20. So that is going to be the width of my rectangle. Again, in general, I have 11 to 21, but I'm interested in 14 to 20. So my width will be 20 minus 14, it will be 6. Right, this distance here is 6. And again, the height is 1/10. And if I do that, I'll have 3/5. For F, I want x less than or equal to 13. So again, I've got 11 to 21. I'm interested in 13 and below. So the width will be 13 minus 11. And again, the height is still 1 over 10. And that will give me a probability of 1/5. The last problem for this example is to find the 60th percentile. So remember, 60th percentile means that the area at some point, I'll call it A, and below is 60%. So the width of my rectangle is A minus 11. The height, remember, is still 1/10. And the area is 0.6. So I'm going to set up my equation that A minus 11 times 1/10 is 0.6. I'll multiply both sides by 10 and get A minus 11 is 6, and then add the 11 over, and I get that A is 17 minutes. So the 60th percentile is 17 minutes. We'll do one more example. Let x be the time it takes to finish a certain test. Then x is uniformly distributed with A 60, B 100. So it takes people anywhere between 60 and 100 minutes to finish the test. I want the probability that x is bigger than or equal to 80. So again, if I look at my picture, I've got 60 to 100. The height of my rectangle is 1 over 40, because 100 minus 60 is 40. And then my rectangles are going to look like either here, so some number minus 60, or it can be over here, and it will be 100 minus some number, or it can be somewhere in the middle, so it would be the y minus the x. So in our case, we want x greater than or equal to 60, so we are interested in this yellow area over here. So the width will be 100 minus the y, and the y in this case is the 80. So I have the height of 1/40th, the width or the length, whichever again dimension you want to call it, the horizontal dimension is 100 minus 80. And if I do that out, I get 1/2. B, I want the probability that x is between 70 and 80. So this was that third type that I did in blue. I want between 70 and 80, so the width of my rectangle will be 80 minus 70. So I have 1/40 times 80 minus 70. If I do that out, I get 1/4. For C, I want the probability that x is less than or equal to 90. So less than or equal to 90 means anywhere from 60 to 90. So the width of that rectangle is 90 minus 60. So 1/40 times 90 minus 60. And that's 3/4. And then lastly, the probability that x equals 75. The probability that x equals a number when it is continuous is always the same thing no matter what that number is, and that's 0. Okay, so read through the book, try out the homework, and let me know if you have any questions about uniformly distributed random variables. Good luck!